Previously, we have discussed about different types of microphones. These microphones are converting audio signal to the electrical signal. Whatever the information we are talking, these microphones we have discussed: carbon microphone, condenser microphone, crystal microphone, and dynamic microphone. Based on the different mechanisms, these are converting the sound signal to electrical signal. But at the receiving end, we require a loudspeaker which is capable of converting again this amplified electrical signal to sound signal. Today we are discussing about the basic loudspeaker, permanent magnet moving coil loudspeaker. This moving coil mechanism we have already discussed in the dynamic microphone. Dynamic microphone is working with the moving coil mechanism. Whenever we are giving the sound waves to dynamic microphone, this permanent magnet on the north pole coil is wounded. Similarly here we are using a permanent magnet and a moving coil. We are taking neodymium as a permanent magnet which will give the magnetic field constantly without any change, and we are wounding a coil. This coil is very light coil and heat resistant coil. Because we are supplying the voltage to this coil should be capable of withstanding the heat. So here we are giving the input electrical voltage. This electrical voltage through wire we are giving to this moving coil. Whenever there is a change in the amplitude, that amplitude change will be observed in the moving coil. Moving coil will move accordingly. That's why this moving coil is also called as voice coil, because the voice equivalent electrical signal is given as input to this moving coil. So this moving coil is changing continuously based on the input electrical voltage. Then this moving coil is connected to diaphragm. We discussed already diaphragm in the microphone. Whenever we are talking these sound waves, based on these sound waves, diaphragm is moving. Now after, when we are connecting this electrical signal to this moving coil is varying. Because this moving coil is varying, the diaphragm connected to this moving coil is also varying. That is producing the sound. That's how we are converting the electrical signal to sound signal. We are using a cone suspension diaphragm here, and finally we are getting the sound from here. So this is a basic loudspeaker that was very much popular in TV and music players, previously in the radios also, because of its efficiency to convert the simple electrical signal to voice signal, and the ability to make it with a compact design, a simple compact design. Portable devices can take this loudspeaker. So that's why these 2 points made it very much popular. That's why in olden radios also, in olden days, in every radio we used to observe the permanent magnet moving coil loudspeaker. Here, as we discussed, this is converting the electrical signal to sound signal. But the range is 200 Hz to 3 kHz only. If we give more than this range, example 5 kHz or 9 kHz, small children will speak in the range of the 9 kHz or like that. Those signals, the audio equivalent electrical signals will not be properly given at the loudspeaker end. So there is a range, but this is a wide range of frequencies, 200 mid-range frequencies, audio mid-range frequencies, 200 Hz to 3 kHz. And the decibels sensitivity is 85 dB to 95 dB. Based on this range, the unit for sound is decibel. Bell is the scientist name. We have to write D in small letters and B in capital letters. Impedance generally 8 ohms to 16 ohms. We observe the speakers in the range of the 8 ohm speakers and 16 ohm speakers. These are some specifications of this permanent magnet moving coil loudspeaker. The main disadvantage with this speaker is, for the high powers it will not work. So if we use for 1 watt to 5 watt input power, that is fine. More than that, we should not connect this one. So modern day speakers are dominating these PMMC speakers, but still they have revolutionized the audio technology. In the basic all audio public address systems previously, in order to communicate in the range of the 200 Hz to 3 kHz, they were the best compactable loudspeakers that were used. But in modern day speakers, they are dominating these PMMC speakers. In PMMC, what is the magnetic material we are taking? Permanent magnet, neodymium. The wire we are taking, the wire should have lightweight or heavy weight? Lightweight. And it should be heat resistant, or there is no need of heat resistance. Heat resistance, because we are giving the electrical voltage. If it melts, then it will not convert the electrical signal to sound wave. These two properties are important for the moving coil. Based on the electrical signal, this moving coil will vibrate, and this is becoming electromagnet now. Until now it is magnet, because we supplied the electrical signal to it, it will become the electromagnet. This electromagnet will move according to this amplitude of the electrical signal. Then it will vibrate the diaphragm. From the diaphragm we will observe the sound. This is how permanent magnet moving coil loudspeaker will work.